how do we do this? Like you come up and introduce me, or I talk? Or
Oh.
Sorry,
So
I don't like overstepping.
It's okay. Normal people would do that. Hi everybody. Thank you so much for coming. It's so good to see so many people here today. I am Nano, the president of Tech, the Emerging Coders Club. Thank you so much for coming to our professional development program. Here we have Mohammed, who will be sharing their experience with career-driven projects in tech from Emerging Realities. Please welcome to the stage.
Right, so good evening everyone. As I said, I'm Mohammed, and today I will be presenting to you about careers and projects in tech. So before I go further into my presentation, I would like to acknowledge the traditional custodians of this land on which we live on today, the Turban and Jaguar people, and extend my respect to elders past, present, and emerging. Alright, so I would like to start the presentation today with about me section. I did structure the presentation as per Edano told me, so yeah, she said put about you section, so I put about me section. So, well, I'm a final year student at the University of Southern Queensland, studying Bachelor or majoring in Computer Systems Engineering, and it's an honors degree, so we get to do a thesis. Yay, I guess. I am passionate about programming and developing better systems to elevate people's lives in general, and to working on projects that matters, some facts about me that I'm currently a student senate representative in the sport field, and I like badminton, so I'm a member in the badminton club at the university too. Okay, so also I thought before I go in there, this photo was at the engineering club. So this is, you can see Alana from ACS and Zaya, and this is Anish from the president of the engineering club. And this is the president of the badminton club, by the way. And this is me. So about me, this is the timeline or the journey. From 2019 to 2023, I was working as a pharmacy assistant and a dispensary technician with the Infinity Group Pharmacy. And the reason why I put an asterisk there because I'm currently still is till now, well, the only source of income till now. In February 2024, that's when I started my work experience in the first engineering consulting firm, which was ACOM in Fortitude Valley office, and I really liked it. It was so nice. I was working with the buildings and places team to deliver a project that related to the 2030 Olympics, 2032 President Olympics. Sorry. In May 2024, that's when I was the vice president and communications co-secretary of the engineering club, where I helped to organize the ball that you saw the photo earlier. In December 2024 until current, well, I got offered the work experience with Emergibg Realities as a game developer, and that's when I was offered the position with the student senate at UniSQ as a sport representative. Okay, so the technical content of today's presentation, spotlight on Python and C/C++. Why is it important and why does it matter to industry? And there are actually multiple reasons, but the thing is, Python is the basis of the development of so many of the current AI technologies that we know of today, including machine learning, processing of big data and data analytics, as I will be presenting in the next slides of the next content. LLMs, which stand for large language models, computer vision, which I did also a project on using Python, but that's not what I'm discussing today. So on the YouTube channel, and other robotics and mechatronics development and training, and many more applications. That's with Python. With C and C++, it's important for embedded systems. So if you wanna do, for example, an elevator project, which I did, that was one of the projects I did work on, was in C, was in an IT called MPLabX. The other projects you could do in embedded systems, for example, like if you want to develop an earthquake measurement system, Although I did program that on an Arduino board in JavaScript, you could also program similar systems on other boards that get programmed in C and C++. Also, C and C++ are very useful in game development, such as in Unity and GameLoft Studios. Alright, so then three free resources to them, or ones that I have personally used and tried. I would start definitely with Stack Overflow, because like who doesn't use Stack Overflow? Like, you know, everyone uses Stack Overflow and Geeks for Geeks, and they are free to use, and they have most of the open forums for your most of your programming languages. And Coursera, that's if you want to do further courses or further like extra like kind of curriculum or extra like knowledge on top of your base knowledge already. So, okay, so the project I will be presenting today will be about data analytics and regression models in Python in Jupyter Notebook. So if I just imagine I wasn't using the microphone till now. Okay, it's not even on.
We can hear you. We can hear you, okay?
We can hear you, yes. Not very well.
Okay.
It's alright.
Well, I turned it on, so sorry. That one. You cannot see that thing. Can you let me in the? If I exit. Control and okay. So I have in that project I do have two things to well, it's two parts I would like to share. So in here we are being given a huge data set that's full, as you can see here, full of different diseases or different situations, different cases, okay? So you can see here that there is cancer cases, there is alcohol, tobacco, etc. Okay? If we go in the next cell, you can see that I did use a filter for topic filter to see the amount of cases per each disease. And you can see the maximum that we got was for cancer, where recorded 176,339, while in the cases that are impacted with disability were 3,922. Then I applied another filter just to show us the rows, okay, and we can see the first 5 rows and the last 5 rows with cancer. And one second. Okay, so we can also see the locations as well. I thought to point that out and some of the other details. Next part is where I did do take all, because the dataset, as I said before, has other diseases, and we don't want all of the diseases. We want only to work on cancer diseases in this case, or for the problem that was being presented in the project. So I took all the let's stop working. I took all the cancer-related cells or cases and transferred it in a new dataset file called cancer dataset CSV. Okay, so the next part is that I load the data again, but this time notice that I'm presenting different parts of the dataset. So I'm not just presenting the rows, I'm presenting the questions, if you can see here, okay, the question part. And I'm also presenting the data type. So some cases are recorded in numbers, some are recorded per 100,000, some are recorded in percentage, etc. And I am also showing the gender. The different column headers. For example, you have a stratification category, ID1, and you have data value type ID. So you will have different, the data set, like I'm just trying to flesh out the data set, as you can see here. So the next part is that I do present, I want to now see all of these column headers in the newly created data set for cancer, and those are the ones. Okay, so you can see the year start, year end, location, etc. Topic, question, response, and all of these ones. So I do another filter, okay, so I can just see the values that has number or per 100,000, okay. The next part is that I do apply another filter just to see the year start from 2015 and 2016, and you can see the number of cases in each one, all right. The next part is another, I just did also again present all of, this is kind of repeated because I didn't present that before, but the part that what really matters is the bar graph where I did the plot to show the number of cancer cases in 2015 compared to 2016, and there wasn't much difference. The next part is where I divide that even further to compare between the number of males and females in who were impacted with cancer in 2015 compared to 2016. Now this is a bit considered light. I could have done much more analysis than that. But the point that I'm trying to get across here is that we use Python to make some visualizations and give us some informative statistics for these people who are impacted, or these cases that are impacted with cancer. So the next project, or the next part, which talks about regression models, and I will try to go quickly through that because there is too much in it, and I'm sorry, I do feel I did talk a lot, but and basically we're being given another data set, and this time it's with an health insurance company, and the data set with the health insurance company shows us different parameters like the age, like the BMI, the region inside the USA, so either northeast or northwest, southeast or southwest of the USA, and the charges applicable. The task to solve the problem is that we want to tell the insurance company what is the relationship between the charges and age, charges and BMI, charges and charges and the number of children. Okay, so I do again flesh out the data. Okay, and then I do find the number of duplicate rows. Okay, and down later, I'm not sure if that's still here, but down in another cell I will be getting rid of the number of duplicates. I will come back to that cell later. But yeah, in here you can see that there is no duplicates for each of these like kind of column headers. Okay, so the next part is that we do now want to look at the charges data. Then we do so we do pick the numerical values from age, BMI, and children. So we can do that some data plotting on it. Then we do use a model called the model is random forest, and in the random forest we use it so we can show the feature importance or which kind of value that is affecting the most. So you can see that the most value that has done some effects here was the smoking, and it has an effect of 0.6894 compared to the lowest one, which is if they are located just in southwest. And I know that's pretty vague because they could be southwest and they could still be high smoking, but I'm just comparing generally. Okay. The next part, I noticed you're all silent. No one has any questions? Because
You're doing good.
Yeah, you're doing good.
I'm already student. Okay. So the next part is we show the box plots and the outliers. And as we can see here, most of the box plots are normal, except with the BMI and the charges, where we can see that there are multiple outliers in BMI and multiple more outliers in charges. Okay, so the next part is where we remove the outliers, and you can see the data before, the data shape before we remove the outliers, and after we remove the outliers, decreasing from 1,338 to 1,193. The next part we do the train split function, which splits the data, because we will need to split the data, which is this cell, to do further plots, as you will see down the line. Okay, so we do then present the different models that we have. We have linear regression, decision tree, random forest, as I did do earlier, and the SVR, or it's meant to be SVM, but and SVM stands for support vector machine. But yeah, it's not meant to be spelled like that. It was the wrong step. But anyway, these are the scores for each of these models, but we will refer to them down again in a later cell. I will come back to them. So in this cell, I do some of the plots to show you the values and the graphs. So in here, you can see this is the linear regression model. That's the actual versus expected. So the expected is the red line, and the actual is the value that we got from that model. Of course, based on our dataset values. Same thing again is repeated from with a decision tree, and I want you to notice that the values that we were getting with linear regression were a bit far from the actual, were a bit far from the expected, while with decision tree, many of them were close to the expected. Many of the actual ones were close to the expected. The next one is random forest, and also it follows similar suit to the previous one, which is the decision tree. The last one, which is the SVR or SVM, and that one is very kind of linear, horizontally linear, so that one has failed this kind of test or plot. So this is another visualization doing the same thing. Don't worry about that one because it's repeated. The next part is we do see the count and the charges. Okay, and you can see the higher the count, which is logic, the higher the count that you have, the more charges you should have. But we noticed that the majority of the cases that we have in that data set are having less children, or they are not that many. So that's why the first area from $0 to $10,000, that's 10,000, right? Yeah. From $0 to $10,000, the majority were at over 200 cases. Okay, while the ones that had so many children or so many multiple people, these were the fewer cases. So therefore, they were between the 0 to 25 range. These were a bunch of representations for other plots. I will show them in a much clearer way, but the point of this one is to show you the ratio and the relationships, which is the main solution for our problem that I said earlier, where we are trying to create a relationship between the age and the charges, the BMI and the charges, and the number of children and the charges versus the charges. And the last thing is the ratio between each variable and the other, the last heat map. I will show them in a clearer cell. These are your histograms, okay? And you can see the counts of the age, how many people, for example, between 0 to 20, how many people between 20 to 30, etc. Same thing applies with BMI, and we notice that the highest value is, I think, before 30, so that's maybe 29. So these were the people who, 29 cases that had BMI over 60. The next one is the children, okay, where we also notice that as it links to the graph before, as the majority of the cases had no children. That's why you saw that the majority in the earlier graph, we saw that the majority of the charges were for the case 0 between, or the counts between 0 to 10,000, because they had no children, they were just by themselves in these cases. The last one was the charges one, and this shows you basically how many people have, how many cases have that number of charges. And also you can see, which links to the graph at the top, that from 0 to 5,000, that was the highest kind of range that people, or the number of cases that people had. And then the more the charges increase, the less the number of people, or the less the cases are. Alright, so next up is the heat map in a more clearer manner. You can see the ratio, so you get to see the ratio between the age and the charges, the BMI and the children, etc. You get to see like basically the ratios between all of them. Do you want to have a read of that?
So what's the numbers for again? It's the
Ratios between the different variables. So you will have, I can zoom in if you want to.
Is this minus 0.061?
Yeah.
Because which means it's the opposite, right? The inverse relationship, if I understand it correctly.
Because some variables are affecting it in a positive way, some variables are affecting it in a negative way.
Yes, that is I guess not that much.
Sorry, can you like raise your voice? I didn't hear you. Can you repeat your question again?
No, it's fine. It's fine. You can keep up the
Okay. No other questions? Okay. Cool. Okay. So I do still present. This is another representation of the data here, where I get to now show the graphs. We showed the ratios. Now we show the graphs. So this is the same. Those three graphs were the same graphs you saw earlier. That I said I will come back to, but in a much clearer, zoomed out way. Also for the marker, they can mark it right. So yeah, this is the relationships. You can see the PMI versus insurance charges, and you can see that you will find some outliers, but the majority were sitting between the BMI of 30, from 40 to 20, and the charges there were majority from 0 to between 10,000 and 20,000, so about like 15,000. That's the majority of the cases in the data set, at least. Could be real life different, but I'm talking based on the data set. The last thing, the second thing is the age against the charges, and you can see that the more the age, the charges increase, while the lower the age, the charges are decreased. But that's not always the case, because some people are in different tiers, or some people have multiple than one, more than one kind of child. So you still cannot have all the young people having low charges and all the people having high charges. But we can safely assume it is directly proportional relationship. The last thing, it's a linear relationship here, where we see that the more also the number of children, okay, the more the charges has increased. And you can see here that there were very few cases that had more, like 5 children. Okay, those were the very few ones, which also matches with the previous graph that we had here. Okay, if you can see here, matches with the previous graph, so we know that we're analyzing at least right. Okay, so in here, I did evaluate these models because we want to now find out which regression model had the best scores. I did actually 2 kind of evaluations, okay, but in both types, I managed to see that in both types of evaluation models, I managed to see that support vector machine and linear regression were high in the first model. The second model, from the top scores, you had the decision tree and support vector machine also were ones of the top high performers. So in the end, we can deduce that, or we can reflect on that. Okay, we can reflect on that the decision tree and linear, not that is not decision tree and meant to be the other one. Should I actually change it? Should be based on the grid. Sorry. It's meant to be decision tree and support vector machine. Those were supposed to be the ones I did not type them right. Sorry. Okay. So the support vector machine and the decision tree were the highest performing ones. And this project was shown you the example of how Python could be used in data analytics and to provide us with the visualization and it can allow us to make informed decisions. Okay, and as seen, we can process huge data sets because these CSV files that I showcased, whether the one that had the different diseases or the insurance one, you can see that these CSV files had so much data in it, but by using filtering and different data analytics techniques, we managed to only narrow it down to only a specific field that we wanted to view or to analyze or to extract certain information out of. Because actually, fun fact, when I tried to open these CSV files just in your normal Excel, the Excel crashed, it errored. So that's where Python in data analytics comes in. Here you go. Reflections. This part, I was being asked to reflect on my journey as an international student for most of my degree here in Australia. And these were some of the questions that used to come in my mind across the 4-year degree. Now it's almost finished, only 1 trimester left. So yeah, what's it like being an international student here in Australia? It is a bit hard and it comes with challenges, and the market is competitive, and I know that some companies will only hire domestic students, and I know that some companies will, in certain areas like defense or certain accounting firms, etc., will only hire people who have citizenship, with security clearance. I know all of that. But yeah, well, if you're passionate about something, you will keep going for it, and you will definitely keep pushing forward to complete it or to finish it. The other thing, is there anything I could have done better? And here I'm talking about myself. I think there could be. I think I could have taken more courses other than that. Just not being kind of satisfied enough by the different electives I had in my degree. I think I could have done courses outside of my degree, but I was so kind of consumed in my degree. But definitely this was something to improve on. My code always errors what to do. This always happens with me, specifically with troubleshooting. When I build a file that is 100, 200, 300 lines of code, and it's always erroring. And this always happens in C and C++ specifically, more than in Python. And yeah, it's a matter of patience and keep trying, and also talking to my lecturers. That's how I was solving that issue. The other thing is that, is it worth it, or I should consider another major? The answer for that question was, I would have said yes if I was in my 2nd year maximum, tops. I wouldn't recommend doing that if you were after your 2nd year, because then it becomes too hard. And I know that if you did civil engineering or you did mechanical engineering, you would be hired on the spot, because these are I got told that even in my face by a company, one of the company HR, I did interview, and they told me oh, we're looking for straight engineering majors. And in another situation at the Careers Expo, another company representative told me, oh, your major is niche. So I know it is niche, because nobody will want someone who have a little bit of software and a little bit of electrical. People would either pick electrical or software. No one will pick someone who has a little bit of this and a little bit of that. But the choices have been made now, so and what's it like the experience with the current job market at the moment? Yeah, it is hard. It is very competitive. I remember one of the interviews I did at an engineering firm. There was, she said they received across Australia 20,000 applicants. And they filtered them out, including the ones that myself for the interview, across Australia were 200. And in the office that I was in, there was only 28 people. So I want you to crunch these statistics in your mind and calculate the percentage. I'm not gonna tell you the percentage, I will leave that with you. But that's to show you the scale that we're playing in as international students here in Australia. Also, I remember when I was working in ACOM, and that was in 2023, so 2 years ago. The HR lady told me we received, just for the internship program, we received about 3,600 applicants across Australia and New Zealand. And she told me, for only how many roles? We had 200 roles. Only 200 roles as well. And we only filled 128. So I asked her, okay, what is the rest? She told me we couldn't find someone competent. From 3,700 applicants. So that's just to give you some insights. So the last thing is let's connect and collab. If you have any, this is my LinkedIn QR code, and this is my YouTube channel. The LinkedIn, if you want to connect and message me. The YouTube, if you have an idea for a project that you want yourself and myself to work together on, then I'm happy to do so and publish it on that channel. And tag you in, of course, and put the credits and everything. But yeah, I will put those there if you want to skip. The last thing is that thanks for listening through, and thanks for Emmanuel for that opportunity to present to you today. And if you have any questions, please feel free to shoot. Thank you.
Thank you. During all your internships, like doing the interview processes, what was the most common thing that they asked you to do?
Depending on the environment. So in engineering consulting firms, usually I got asked in the interviews where I get tested in a consulting environment. So a client walks in, whether it's the state premier or the Department of Tourism or whatever, they walk in, that's the question that they give. And they want a project that will reshape the city of Brisbane, for example, and you're being asked okay, you're now working with a team, okay, and the project is gonna be too complicated, but the client is mainly focused on sustainability. Tell me what will you do, or an idea of a project that puts sustainability in mind while designing that project. That's in consulting firms, more of theoretical stuff. Now, if you want to get into technical stuff, if you go, which was one I did with TikTok, they gave me an assessment, okay, of 5 questions for a software developer. It was 5 questions. It was that hackathon similar kind of design thing, where you have a 2-hour timer. The 5 questions has 2 coding 2 coding ones and 3 MCQ ones. And I scored terribly in that one because I was like when I was running in that IDE that they give you, because you don't get to run your code in your IDE. You have to run it in the same test environment they give you. You don't get to see the outcome, you only get to see the test example outcome. So they will have for example, an input that goes into your code, and then their machine or their test example is giving out an output. It's meant to be giving out an output. If the output matches their correct answer, then you pass. If it doesn't, then you don't pass. Okay, so how do I know what's the error? It tells you error, but it doesn't tell you what's the error. So it tells you your code error, but it doesn't tell you it's syntax error, it's name error, it wouldn't tell you. That's how hard it was. So depending on where are we doing the interview? Another place also I did an interview in was with Amazon as well. But this time they were merciful. They gave me only one coding question that they gave, and it was not timed. I didn't have time. And then they gave me 3 MCQ as well, 3 multiple choice questions. And that one was easy. I managed to pass that one. But then in the end there were competition. Further stage of the interview, and I still got eliminated. But yeah, it is what it is. So you don't get to choose, I guess. You get to just go through the experience. So yeah. Any other questions? Have I at least answered your question?
Oh yeah.
Yeah. Okay.
I feel a lot more prepared now.
Okay. Oh good. Well, if there is no other questions, then okay. Yeah. I should.
We just want to know, this Jupyter notebook, we are doing something similar. So it helps in business analytics stuff.
This helps in everything. The amount of libraries that this notebook comes with, it comes with libraries that you can use for LLMs. It comes for libraries that has statistics. It comes with numerical libraries for mathematics. It comes for libraries for everything, everything you can, most things. Some things you have to import. But most of the things you would typically do, it comes by default. If you work it on MATLAB, you know MATLAB?
Yeah, I know MATLAB.
Yeah, same thing. It comes with so much libraries that when you start plotting your graphs or everything, you will see everything on them. And if you also have specific questions about certain libraries, you can always go in the forums, and I'm happy to help you also if something I've worked on or library I worked with before. But yeah, you can use it in so many applications. Not just data analytics, you could use it in much more applications than what I have shown.
And you talked about the CSV file,
Yeah.
you open it in directly in Python in Jupyter, in CSV environment.
I launched it. The reason why I launched it in Jupyter because, I displayed it. I chose to display it in Jupyter because when the CSV file was, datasets are huge. They collect like large sums of data. When I did try to open it to see the file itself in Excel, because Excel can open CSV files, but within a specific size. It errored because it was more than the number of rows and columns that Excel would allow. So I was like, okay, that I gotta work with something here, I have to be, because I wanna filter out, I wanna choose to work only on kinds of cases. So
So where you opened the CSV file in Jupyter itself?
Yeah. But that's how if
that one.
I can show you in the, if I can, wait, sorry. If I open that back again, you get to pick the file name, and then it will and present the data. You get to present it. One second. So for example, with regression models, in here, once this loads, I can show you the.
This insurance.csv is the data set,
Sorry?
The insurance.csv is the data frame you are using.
That's the data set, yes.
Yeah.
And I make, if you see, I use pt.read.
Yeah.
Well, you need to import pandas as
yeah.
pt first and import numpy because we're working with numericals here. But yeah. Any other questions?
Well, I don't have a question, or I guess my question is would be a bit technical, I guess. But then, so this insurance, the goal is to predict the insurance charge, the correct insurance charge, right?
Yeah, the goal was to predict the relationship between the insurance charges and the different factors that a client could have that will determine that charge. For example, if you're a client, let's say I am Mohammed, I don't smoke, I don't have children, and my BMI is 30, for example. Okay? What my charge will be, for example, what will be my charge compared to, let's say, your name is Tuku, is Tuku. Tuku. So Tuku, for example, someone who smokes, he has 4 children, and his BMI is 60. Tuku's, based on the model that I presented, Tuku's charges will be much higher than me. If you go, and it sounds logical, because you have more children, you have more health, you're more you're more prone to get cancer, lung cancer and other diseases because you smoke, while the person here does not smoke, so they're less prone to get health issues. And they don't have children, so they don't have dependents to cover.
So, I guess I want to ask further, let's say the model predicts wrong. If it's predicting higher, what happens? And if it predicts lower, that is what happens.
This question is hard to answer. When you say it predicts wrong, how
Let's
will
say
it predict wrong?
we have the data set like that, right?
Yeah, but some models will predict definitely wrong because they are not designed for that problem.
Yes, but we want to minimize the loss, right?
So this model, for example, did predict wrong. It is predicting wrong. The values are meant to be near the 9.
My question is that should we drop this down further, or should we increase this further with the price of maybe this one go higher?
It's not gonna. It's not gonna. You should not do that neither the other one because the model that does that is meant to be this model, not the other one.
Can't prove the data, right? The data.
You can
That is the original data of the original data which
It's not. This is not me. This part is not me. I'm just quoting the stuff. The part that where I come in is this line. This is the line of best fit. This is what the model does. But these I don't control them.
Like if your model's predicting wrong,
So
then
this is the
it's
model,
different
the middle
model,
is
isn't
a
it?
line, the model is a line. So let's see. Can I check they train using the mean square error.
Yeah? Yeah, well, they don't train using the mean square error. I just told to display that there, like as a value, but I
Yeah,
they don't train
so-
using it.
This part
Just
train
calculating.
model that fit, but it's trying to fit using the train and YJ, right? So what loss is it using here?
The linear y equal mx plus c should be that. That's what it should be.
So the mean square relativity.
That's not the same. That's not the same equation. Look up the mean.
Oh, that's
It's not the same. Sorry, it's not the same.
I was supposed to remember this, but I guess
No,
I
it's not.
haven't.
It's not the same equation. I'm 100% sure.
Alright.
Just one second.